The third method that we can use to solve these system of equations is called the elimination method. In a nutshell, you add the two equations together and it eliminates one of your variables, so then you can go solve for the remaining one. And then you kind of plug it back in and substitute just like a substitution method. Let's go through these steps and you'll see it play out. When you look at these equations, when to use this elimination method, well, look to see if your like terms are lined up or stacked up. Your x's are on x's and your y's are on y's, or hey, just numbers are on numbers. Okay, so that is the sign of like, yes, we want to use elimination method for this. Now, step 2 is something that you do sometimes, but not all of the time. You're looking to see, do I need to multiply one of these equations so I can get the opposites right on top of each other, right? It says multiply one of the equations by a number that will cause them to be like negative 2x and 2x, or 5y and negative 5y. Do you see right here that we've got a minus 2y and a plus 2y? That means that this step is not necessary. Meanwhile, if you look at this one over here, I've got a 3x and a negative 2x. And then I have a positive 4y and a positive 4y, not the opposites. So this one, the step will be necessary. But this one, we can skip right over this step. Now this is where people go, I really like elimination method. Step 3, add the two equations together. So how does your brain process this? Well, just look at your x's and add them together. If I don't see a 1 right here in front of the x, then add a 1. So 1x plus 5x is 6x. And then you move on to the y's. And so as a result, you're using this minus sign, but you're thinking of it as if it was a negative sign. So it's negative 2y plus, and you're using this plus sign as a positive. Okay, so it's negative 2 plus positive 2. Well, that cancels, right? Then the equal sign drops. And we have negative 18 plus positive 1. So step 3 is completed because we were able to add the two equations together and it canceled out one of the variables. Okay? Step 4. Well, step 4 is talking about, hey, would you please just solve this equation right here? So get the x by itself. And there you have it. We already have half of our solution, this ordered pair. We've got the x. Now we just need to find the y. Step 4 is complete. Well, just like in the substitution method, after you found the first one, we're going to take this negative 3 and we're going to put it into one of the original equations. I kind of like the x being here all by itself because we can make that 1 go away. So how about we make that x into negative 3? Then we're going to solve it, and you can see my typo right there. It's solve it to get the second variable's value. So we need the y, and there it is. So go get this y all by itself using your normal equation skills. Step 5 is complete. We have our second variable's value. So step 6, write your x and y as an ordered pair. And that's it. That's the complete elimination method. So if you're ever able to look at these equations and they're already stacked up for x's and y's, just add them together and hopefully your x's or y's will cancel out, leaving you one of them to go solve for, and then pop it into one of your original equations to go get the second variable. So what do we do if we can't just add them together? Like this one. You know, when you add them up and you still have x's and y's after you do it, well, sorry, we've got to do that second step. It becomes necessary to change this. Gee, wouldn't it be nice since these were both 4s that one of them was a negative 4 and the other was positive, so it could just cancel, just like we did that right there? Well, it's very possible. Choose the equation that you want to work with, put parentheses around the entire equation, and then just choose a number that you could multiply that by to make it what you want it to be. And you can change the number too. Like if I wanted to make this negative 8, I would times it by negative 2. But I just want to make this one -4, make this plus sign into a minus, right? Make it into a negative. So I'm going to times this by -1, but I'm going to times everything in the equation by it using the distribution property. And we're using the signs in front of this like we normally do. So -1 times +4 is -4. And then -1 times 18 is -18. Now, I don't normally like to do this, but I'm doing this to show you that we don't want to use this equation anymore because we had to change it to make it into this one. The second one we never touched, but now we can add these two equations up, the changed first one and the original second. And you can see here +4 and -4, see it works out perfectly. This cancels. That's why we multiplied this by -1 to get what we wanted. It's just it changed the x's and this one as well, but that's okay. We can deal with that. The big thing was we got one of our variables to go away. So go ahead and solve. And I know that was kind of quick, but I'm expecting you to be better with this at that point. Now, we have our first variable, and just like we did over here, we're going to take one of the original equations. We can use this one that we're not using anymore, or we can use this one. Choose one of them. I kind of like this one because of smaller numbers. You can see that this x is multiplying the -2, so I'd like to put parentheses next to the -2 to show that, hey, whatever we slide in is going to be multiplying the -2. Now go use your skills. Parentheses, drop the rest, and now solve your two-step equation. And there's our ordered pair. This solves our system of equations, 2, 3. The third one, there's a typo in it, and I'm not going to talk while I do it. I'm just going to have us fix the typo, and then you're going to see me go solve this without talking.